Okay guys, so today you're going to be doing the math portion of the convex lenses. So hopefully by now you've learned how to like draw the lens diagrams, the ray diagrams, and see what happens when an object is, placed back here, or placed in between 2F and F, or placed in front, and kind of what happens with those as you manipulate where the object is in relation to the lens. So now we're actually going to add some math into that. And I did change the assignment a little bit from what it was on the blog before. So make sure that you print the new one or just do the old one. That's fine too. But this has a little bit more practice for you. I have 4 practice problems. I'm going to do the first one and show you how, and then you can do the rest hopefully on your own because they are very similar. Okay, so it says, number 1 says a 15 centimeter object is placed 45 centimeters from a convex lens. The lens has a focal length of 15 centimeters. Draw a ray diagram and solve for the image distance, the image height, and describe the image. So when you're thinking about these problems, I want you to know that the focal length is to the first F right here. So it's from the lens to that first F. 2F is actually double the focal length. So if the focal length is 15, so that's from here to here is 15 centimeters, from the focal length to 2F will be another 15, which makes that 30. Okay, so I'll put 30 right here. So that's really like 30 centimeters right there. Not technically, not like I'm not going to take a ruler and measure out 30 centimeters, but to scale, this would be about 30 centimeters. So when it says that our object is 45 centimeters, 45 is going to be somewhere past the 30. Okay, so that's going to tell you that you have an object that is placed beyond 2F. So let's go through the problem right here, and I'm going to label all the numbers, and then we'll come down and do the rest. All right, so it says 15 centimeter object. 15 centimeters is going to be the height of the object, so that's HO. It is placed 45 centimeters. The actual object is placed 45 centimeters from the lens, so that's going to be the distance of the object, which is DO. The focal length is 15. That stands for F, and then we can complete the rest of this with those numbers. So if the focal length again is 15, then this would be 30 because it's double 15. And I'm going to place my 15 centimeter height object 45 centimeters. So if this is 15 and this is 30, 45 would be about right here. It doesn't have to be exact, but just somewhere in that ballpark. So 15 centimeters is about this length, so I'm going to draw an arrow that's about that high. Okay, now I'm going to draw my ray diagram. So remember the phrase parallel through F and through F parallel. So I'm going to start from the top of my object and go parallel, and then I'm going to do that a little bit better because it looks like it's slanting up just a little bit. I'm going to go back and retrace that to look a little better because the precision is key on these. Okay, I like that better. So parallel, and then this is going to be F on this side, and this is 2F. So I'm going to take my ruler, parallel through F. Okay, that's my first line. And then through F on this side, back to the top of the object. Through F, hit the lens, and then go parallel to the principal axis. And make sure everything is lined up just perfect before you draw your line, or else you'll get something off. Okay, so here you can see that's the intersection of where my image is going to form. So I'm going to go from the axis and draw an arrow down. So I can see that it's a small arrow and it's pointing down. So that's going to help me with when I'm going to describe my image. All right, so the first thing, I'm going to find the image distance. So my formula for that is going to be 1 over F equals 1 over DI plus 1 over DO. F here is where I labeled my numbers, so 1 over 15 equals 1 over, I don't know what that is, plus 1 over DO, which is 45. All right, then I don't like fractions, like I've said. So I'm gonna go ahead and put these in my calculator to simplify the fraction. So 1 divided by 15 is 0.067, I'm gonna round up there, equals 1 over di plus 1 over 40. Oh, let me actually, I won't put 1 over 45, I'll do that. 1 divided by 45 is 0.022. Okay, so I'm adding here, so I'm gonna subtract 0.022 under this side. So 0.067 minus 0.022 is 0.045 equals 1 over di is what I have left over on the right side. I'm not done, so I need to multiply di by both sides. Cancels over here. I'm running into my height, sorry. And then, sorry, I lost my spot. Okay, di times 0.045 equals 1. And then I'm gonna divide 0.045 under 1 so that di equals 1 divided by 0.045 is 22.2 centimeters. So over here, I can see that this, remember that the focal length was 15, and this would be 30. So 22.2 would make sense because it's in between 50 and 30. So I like that answer, so that's good. And then it says to find the image height. So I'm gonna go over here and I'm gonna say HI over HO equals negative DI over DO. Okay, HI I don't know. What is the height of the object? It is 15 centimeters equals negative DI was 22.2 and the distance of the object was 45. Okay, so I can say that I'm gonna simplify this side. Negative 22.2 divided by 45 is HI over 15 equals negative 0.493. And then I can multiply both sides by 15 to get that out of the bottom over here. So HI is going to be equal to negative 0.493 times 15. Okay, and negative 7.4 centimeters. So going back to our diagram up here, that's the height of the image, HI, height of the image. So if I'm looking at, this is the object, and this is the image. So the image is actually smaller than 15. You can see how that arrow is a lot smaller than that one. And it's actually about half. So if this one was to scale, it's not, I didn't draw exact, but to scale 15, this one's smaller, 7 is less than 15. The negative tells you that it's going in the opposite direction, which is down. So I like that answer as well. So if we were to describe the image, I would say that it is smaller, right? Because 7 is smaller than 15, so it's smaller. It's inverted, because it's upside down. And anything that's inverted is also called real. So I say smaller, inverted, and real, and that's all I need from there. So this would be a complete problem where you have drawn the diagram, you solved for the distance of the image, and you solved for the height of the image, and you were able to describe the image. So there are 3 more for you to practice with, and those are your notes for today. So good luck. Let me know if you have any questions.